Hello everyone, I'm Rekha Bhangaonkar. I'm a postdoctoral research associate at the Department of Land Economy, University of Cambridge. I work on flagship 6 of Tigris, where our focus is on rural education, employment, entrepreneurship, and empowerment. The title for my presentation today is Irrigation Management for Building Climate Resilience, Lessons that we learn from Dryland Agriculture in India. To begin with, I will go about with a brief introduction of dryland agriculture in India. Dryland agriculture constitutes nearly 2/3 of the cultivated land in the country. In the image here, the light and dark pink regions are the dryland regions. They contribute to nearly 40% of food production and provides employment to nearly 50% of the population. Agricultural productivity in the dryland regions are heavily dependent on annual seasonal rainfall, and increasing climate risk, particularly variability in annual seasonal rainfall, have been reported as a cause for decreasing productivity in dryland agricultural regions. One of the ways to build climate resilience to dryland agriculture is to invest in rainwater harvesting. Projects have invested in rainwater harvesting, use that resource to recharge groundwater tables, and farmers then use the groundwater to secure a source of irrigation. However, groundwater is a common pool resource, which means that it is difficult to exclude someone from consuming the resource. At the same time, with more resource users, the resource available for consumption also reduces. A way forward is to encourage community-based governance for groundwater resource. So the key research objective is to identify factors that have encouraged collective action in groundwater governance. The conceptual framework that we depend upon is Ostrom's socio-ecological system frameworks, where she defines sustainability of socio-ecological framework as an interaction, a dynamic interaction between resource systems, governance systems, resource units, and users. We are particularly interested in the interaction between the governance systems and the resource users. Our region of study is the state of Maharashtra. This is because 70% of the cultivated land in the state is classified as dry lands. Also, this is the state where most of the drought-proofing initiatives, for example, micro watershed development project and the farm ponds were first initiated. And within the state of Maharashtra, we are looking at the district of Jalna and Ahmednagar. Our facilitators has been Krishi Vigyan Kendra Jalna and Watershed Trust from Pune. We have collected information through farmer surveys as well as from interviews with officers at the Village Watershed Development Committee and the Agricultural Extension Office. We've also collected data from control village and treatment villages, the difference between them based on a micro watershed development program implemented in the village or not. Though groundwater governance has a bigger scope than groundwater management technique, we focus on groundwater management techniques and its impact on groundwater use, both at the village level as well as at the farm level. We have been able to observe three irrigation management techniques, one being that of water budgeting, second being of social capital, and third, private provisioning. The water budgeting tool. The water budgeting tool displays information on rainfall received and the extent of recharge in the groundwater tables. In the figure here, you can see the columns record the recharge level in the monitoring wells, while the rows record an annual seasonal rainfall across various months in that particular region. This information is displayed in a public space in the community, and the community can use this information to negotiate, to discuss, and arrive at a crop portfolio that best uses the groundwater available. For example, in a year of poor rainfall, they may decide to stick with dryland crops only, and in a year of good rainfall, they may include a water consumptive crop in their crop portfolio. A person from the village community is trained to update this water budgeting tool and is typically supported by an agricultural extension agency. Our research findings from this segment of work is that the tool aids in dissemination of information, which in turn encourages collective action for groundwater management. The tool is more successfully used when backed with the support, particularly knowledge support of an agricultural extension office. This is particularly with reference to agricultural intensification and the retweaking in the design of the tool that may be required. Finally, farmers with relatively more irrigation demand are likely to be the conduit between the Agricultural Extension Agency and the community, highlighting their potential as being project managers in the post-project phase. To summarize findings from this segment of work, knowledge-based tools are capable of encouraging collective action for management of groundwater-based irrigation systems. The next model of irrigation management we observe is that of the social networking model. This model has been used by Agricultural Extension Agency to bring in new ideas into the community, for example, the micro watershed development program or the farm ponds. By leadership model, we refer, what we mean is that a few farmers are selected by the Agricultural Extension Agencies. They're handheld in new technology or techniques, and successful adoption by this segment of farmers, or these few farmers, encourages the community as a whole to adopt the new technology. In the figure here, these blue dots are the key agents that the Agricultural Extension Agency did handhold. And we can see that almost all the households in the community are either directly or indirectly in association with these key agents. However, what is worrying is that even when a conservation technology is rolled out in a community, diffusion of the technology itself can be a cause of resource depletion. The case in point is a farm pond initiative in the state of Maharashtra. Farm ponds were introduced to harvest annual seasonal rainfall from a farmland, and farmers could use this resource in conjunction with groundwater. But the diffusion of this technology itself led to reduction of a farm pond as being a unit of just storing groundwater. What we see from the results is that social networking model has been very successful in diffusion of technology. What we observe in the first figure is that the technology adoption time period falls over time. And in 2014 onwards, what we see is that it is almost negative. That is, farmers invest in irrigation assets first and then make changes in their portfolio. What we also notice is that irrigation stacking is a common behavior across all land holding in Dryland regions. Wells being the primary irrigation assets, but farmers are also investing in farm ponds, and common wells being the least popular. So the findings from this segment of research is that social learning from the social networks fostered the idea of community ownership of groundwater. Groundwater was referred to as our water, and if we do not use this resource well, we lose it to our neighbors. Social learning encouraged private provisioning for irrigation. This is particularly when agriculture started to intensify. Collective action have upheld resource use rules. To summarize, social learning shapes irrigation management tools, and it is the social cohesion that upholds resource use rules in the community. A third model of irrigation management is the private provisioning model. Nearly 60% of farmers in dryland regions are smallholding farmers. Kharif and Rabi are the two agricultural seasons, of which commercial farming is possible only in the Kharif season. Farmers aspire to adopt horticulture because it is a symbol of agricultural progress, but more importantly, it is the method through which they can ensure some form of farm income. Farmers are sure of ensuring irrigation to their horticultural crop by investing in irrigation assets. So the table here, we can see that across all land holdings, farmers invest in irrigation assets, not only in terms of wells or bore wells, but we also see that they are investing in storage capacity, like they're investing in farm ponds, and the capacity and the irrigation investment increase as land holding size increases. What we also see is that horticulture is a popular choice across all land holding. And this is possible because horticultural farming exhibit a form of constant returns to scale when considering only the variable cost. So the findings from this segment of research is that in shallow aquifer regions, farmers find it cost effective to invest in wells and farm ponds and choose horticulture as their crop. Horticulture cultivation did not indicate a scale disadvantage to smallholding farmers. However, adoption of horticulture crop resulted in reduction or shrinking of farmers' crop portfolio. In this figure, you can see that smallholding farmers coded as 1 subjected nearly 40 to 70% of their land for horticultural cultivation, while similar allocation by large holding farmers were only 20 to 40%, saying that rest of the land was dedicated to dryland crop portfolios. Finally, farmers are allocating a larger share of land for construction of farm ponds, which is to indicate that when we look at land use, we identify them as changes in crops, but here we also identify them as use of land for construction of irrigation infrastructure. So to summarize, horticultural adoption is perceived effective in mitigating climate risks. Private provisioning for irrigation plus horticultural model is cost effective in shallow aquifer regions. So to conclude my presentation, knowledge-based tools are capable of encouraging collective action for management of groundwater-based irrigation systems. Social learning shapes irrigation management practices. Social cohesion upholds resource use rules. Horticultural adoption is perceived effective in mitigating climate risks. And finally, private provisioning for irrigation plus a horticultural model is cost effective in shallow aquifer regions. Thank you.